Hey everybody, welcome to day one of Coding Nomad's 3-day online Learn Java Live webinar. Today we're going to get started with some very fundamental topics in the Java programming language, such as variables, operators, loops, some if statements, and some arrays. A bit about me as we jump in. My name is Ryan Desmond. I'm a co-founder at Coding Nomads. I've been a Java engineer for over 12 years, and I've spent 5 of those years teaching Java at various levels from fundamental all the way up through advanced all over the world. In this training, we're going to learn two primary things. One is why learn Java, and the second is the most fundamental concepts in Java, as mentioned: data types, variables, operators, if statements, loops, and arrays. So we're going to kind of try to move through this stuff kind of fast and keep it super useful for you. Before we jump into any syntax or any actual Java, let's discuss why someone would want to learn Java. And the answer to that, the reasons for that, are quite simple and super obvious. Number one is it's the most in-demand language in the world and the most widely used language in the world. And there could be good arguments to be made. Well, maybe JavaScript's more useful here, or maybe Python's more popular here. Totally valid arguments. The reason we say Java is number one is because in terms of the sheer number of people using it on any given day around the world, Java just dominates, right? And it has for a very long time. It's used from tiny embedded systems in your car or your phone, all the way up to satellites or rovers on Mars, web applications, big data, mobile applications. Java is simply everywhere. Java also kind of sets an industry standard in that there's several other languages. Python's a really good example that are much much less verbose than Java. And while Java might be a bit verbose, meaning we have to type a bit more, Java actually makes you enforce these rules and best practices when it comes to coding, whereas several other languages might infer those meanings through the code, and they actually abstract that complexity away from the end user. So as you're getting learning and you're just learning programming, Java can have a slightly steeper learning curve. But once you do know Java, it sets you up with a really nice foundation so that you can learn other languages much more quickly. So as it mentions here, Java is a great first language to learn, in that if you become a comfortable Java developer and you go to try to learn Python or PHP or JavaScript or C or any of these others, they're going to make a lot more sense, and you're probably going to be able to learn them a bit quicker. And whereas the inverse is not necessarily true. For instance, if you learn Python first, which is also a great option, super powerful, very, very popular language. But if you learn Python first, Python makes our lives really easy, right? It's a bit intuitive and we have to type less code. But if you get really good at Python and then you go to learn Java, it's going to seem confusing and complex, and why is this so hard, and what's the deal, right? So if you learn Java first, it's just a really good foundation for setting you up really good and setting you up well for learning future technologies and languages. So learning Java in general is just a great idea. It's used all over the place. The job market is strong, and it's just one of those really, really strong skills to have in your repertoire. As mentioned, Java is used literally all over the place in every type of software, from as small, like I said, the tiny embedded systems, all the way up to the world's largest enterprise companies are all using Java. Here's a few examples: Netflix, LinkedIn, Amazon, Slack, Google, NASA, Spotify, Android, etc. Java is used, it's the primary language that powers the Android operating system. And for those of you who are outside the US, you'll probably know that the Android operating system is by far the most widely used operating system on Earth. Here in the US, the iOS and the iPhone kind of has, a larger market share. But in terms of the number of devices around the world that are running iOS or Android, Android absolutely trounces iOS. There's probably millions and millions of more Android devices out there in the world. Don't quote me on that. I'm making up that number. But Android is the most widely used operating system on Earth, and Android is powered by Java. Java can do desktop applications. It can do game development. It can do massive data processing. You can use it at a tiny startup to get a little proof of concept going. You can also use it at the biggest companies in the world to build some of the biggest and most complex applications out there. So learning Java is a really good idea, super widely used, incredibly popular. It can be used in all kinds of scenarios. No matter what kind of application you're trying to build, there's probably a good argument that Java would be a good language to program that application in. So now that we know why we want to learn Java, let's go look at some source code. And we're going to start right at the beginning with Java's primitive data types, right? So in Java, there are 2 types of data. There's primitive data types, and a primitive data type can be basically what makes it unique, or what makes it what it is that a primitive data type can be stored in memory as a single string of bits, right? So like the number 124 or the letter A, or some of these primitive data types where a single string or a single sequence of zeros and ones can represent that data. That's called a primitive data type. The other data type that we'll be talking about in day 2 of this series is object data types, and those are different, a bit more complex. We can design whatever object data types that we want. Super, super useful. Comes into object-oriented programming. We'll discuss that tomorrow. Today we're going to discuss primitive data types, and there are, what is that, 8 primitive data types, and let's discuss each one, right? So the first and the simplest but very, very widely used primitive data type is called a Boolean. And in Java, when we're declaring a variable, so we'll talk about primitive data types and variables at the same time. When we're declaring a variable of type Boolean, we say the data type, Boolean, and then we have a variable name, and this could be anything. Like we could just say coding is cool. You could call that variable name whatever you want. The main idea here is that we want that variable name to be self-descriptive, right? So we don't want to have a bunch of, and it's pretty common to have int I, like int x, and kind of these random variable names when we're talking about numbers and stuff. But the more we can make our variable names and our method names when we get there, the more we can make our stuff self-descriptive, the better, because then when we're reading the code, it makes a lot more sense. So we've got a Boolean variable, Boolean type, its variable name is coding is cool, and we're setting it to true. And a Boolean can have only 2 values, true or false, right? So I can set this to true, or I can set this to false. Those will both work. Any other value is not going to work. We're going to get some kind of error. Here it says required Boolean found int, right? So 1 is an int in this case. So let's just go ahead and say yes, Boolean coding is cool is true. So the first primitive data type is Boolean. It can hold the values true or false. The next 4 data types are called, we use them to hold whole numbers. So like 127 or 4, rather than decimal points, like 3.14. So the smallest whole number data type is called a byte, and it reserves 8 bits in memory, right? So it can only hold the numbers like -126 to +127. That's the whole range of the numbers that it can hold. And this makes a lot of sense if you're writing some kind of application and you're using a variable like to hold the month of the year. Let's say that's 1 through 12 or 0 through 11 if you're counting from 0. That number is never going to get higher than 11 or 12. So I don't need to reserve 32 or 64 bits in memory to hold this tiny number, right? And so that's one of the reasons we have these primitive data types, is that we can reserve only the amount of memory that we need for what we're doing, right? The next largest primitive data type is a short, and it's just twice the size of a byte. So it holds 16 bits of memory, and its range of numbers is a bit bigger. The next and probably the most commonly used whole number type is the int, short for integer. The int reserves 32 bits of memory, and it's gonna, its range is up into the trillions or quadrillions. It's basically gonna hold any common number that we're using on a day-to-day basis. But if we have an extra big number, then we're gonna use a long, and this is twice the size of an int. It reserves 64 bits in memory. And one interesting thing about a long is that you'll typically see when someone's just declaring a long, you'll see that they put an L at the end, and that's to actually tell the JVM, tell Java that we do indeed want this to be interpreted as a long, because sometimes without the L, it can be interpreted as an int. So in a long, you'll oftentimes see a little L right at the end of that number, just to say, I really do want this to be interpreted as a long. So those are the 4 whole number types, right? And then we've got 2 decimal types, or floating point numbers, as they're called in computer science. The first is a float, and that's short for floating point precision number. And these are for holding decimals, right? So something like 3.14 or anything with a decimal place, or any kind of fraction. And again, with a float, oftentimes you're going to see a little f after it to indicate I really do want this to be interpreted as a float, because kind of the complementary to the int, the double is very much the workhorse and the most common one that you see out there in terms of primitive data types when we're using decimals, that numbers that have decimals or fractions, right? And a double just stands for double precision floating point number. And the last primitive data type that we have is called a char, or char, or car. I call it a char. And a char can hold a single letter, and that's it, such as the letter Y. And it's always in single quotes. If I tried to put these in double quotes, That's how Java interprets a string, which is a different data type. It's an object data type. So if I wanted to do a string or a word or a sentence, that would be a different data type. It's called a string that's wrapped in double quotes. A char is always wrapped in single quotes. Otherwise, you'll get an error. And that's it. Those are the 8 primitive data types in Java. We've got Boolean, true or false. We've got byte for our small numbers. We've got short for our slightly larger numbers. We've got int, which is our workhorse for whole numbers. We've got long, which is to hold really big whole numbers. Float, floating point precision number. It takes 32 bits of memory. 3.14, 34.4567. You'll see the F at the end. Double is kind of the complementary to the int, and that is the workhorse. You see ints and doubles all the time. Double just means double precision floating point number, again, for decimals and fractions. And then the char, which holds a single character. So once we understand our primitive data types and kind of how we use variables, keep in mind, again, just as a reminder, for a variable in Java, which is a strongly or strictly typed language, we always have to declare the type of the variable that we're using, right? So that's why you'll see the data type, and it's actually highlighted in dark blue here, which is a keyword in Java. That's what that highlighting is about. We use the data type, and then we create we come up with a variable name. It could be literally anything. This could be star, or, how about dolphin? We can name this whatever we want. We just want it to be self-explanatory. And then we have I'll just set this back to coding is cool, because coding is super cool. And then we have the equal sign, which in Java and programming oftentimes is called the assignment operator. We're assigning the value of true to the variable coding is cool, which is of type Boolean. And down below, we're assigning the value of 123.45. We're using the assignment operator, the equal sign, to assign this value to this variable, double num, which is of type double, right? And again, this variable could have any name. We want them to be self-explanatory. So let's move on and let's look at the fundamental operators in Java. So I've pre-typed this out just so you don't have to hear me clicking and clicking away here. There are 3 primary types of operators in Java. Let's see if I'll just put this on 2 lines down here. The first and kind of the most intuitive are the arithmetic operators. These are the same types of operators that you've seen, all your life in, algebra and geometry and basic math. We've got the addition plus sign, we've got subtraction minus, we've got multiplication, we've got division, and then we've got this other one which you may not have seen or used before called the mod or modulus or modulo operator. Modulus or modulo is the full name. Everyone kind of just calls it mod, M-O-D. So right here, I'm just creating a couple of variables just so that we can use them. And this is an example of using the plus sign, right? So I'm adding 2 variables. Int sum equals a plus b. Here we've got int result equals b minus a, right? Subtracting. This is probably, super intuitive to you. Int, let's call this product equals a times b, right? Multiplication. The little 2 slashes that I'm doing here, just so you know, those are comments, which means that they're ignored by Java, by the compiler. And we can kind of add in some comments and some notes to ourselves, and it doesn't actually affect our code. So multiplication, this now changed. We've got division right here, b divided by a. And then this last one is the modulo or modulus, aka modulus, aka mod. And what the mod does is it divides C by A, so 24 by 10. But these are both ints, keep in mind, and there will be a remainder because 10 goes into 24 twice with a remainder of 4. And in a mod operation, what we get back is that 4. We get the remainder back, right? So if I'm to run this, and then after we do these 5 arithmetic operations, I'm just going to print out the sum, the result, the product, the result of this division, as well as the mod. So for sum, I would expect to see a plus b is 30. So it's going to print 30 dash b minus a is then 10. So it's going to 30 dash 10 dash product a times b. So that's going to be 200, 30, 10, 200. Divide b divided by a. So that's going to be 2. And then mod, c mod a 24 mod 10, that result is 4. So let's see if I'm going to run this, and we'll just look at the first output. Might take a second here to compile on the first run. Great. So it looks like what we expected, 30-10-200-2-4. And what I've done here, just so you all know, this is called string concatenation. I'm basically saying print out this value, and then I'm not this. So this is a little confusing because we're using the plus sign, but we're not actually doing any kind of math. We're doing string concatenation. So I'm saying I want you to print out this plus this dash plus the result plus this dash plus the result plus the dash. And so what I'm doing is building basically a sentence, or AKA a string in Java, that I want to print out to the console. So that's why I printed 30-10-200-2-4. So all of these are very intuitive. You've been using them your whole life, except for maybe the modulus operator. And just as just to put a couple in here, just to help out on future. So let's say I'm going to do a couple of mod operations. So let's say 8 mod 3 is 2. Right? So 3 goes into 8 twice with a remainder of 2. Let's do 15 mod 3 is 0, right? Because 3 goes into 15 5 times with no remainder. How about 20 mod 3? So that's 3 times 6, 12, 18. So that's 6 with a remainder of 2. So 20 mod 3 is 2. Right? We're getting the remainder back into this variable that we called mod after the operation. It's an interesting and oftentimes quite useful operation. So for instance, if I want to tell if any number is even or odd, I can very, very quickly mod whatever number it is, no matter how big it is, I can mod it by 2. If there's a remainder, it's even. Sorry, it's odd. If there's no remainder after modding by 2, then we know it's even, right? So can be quite useful. The next type of operators in Java, the second type, remember there's 3 types of operators in Java. The first are arithmetic, plus, minus, multiplication, divide, modulus. The second type are called relational operators. And these are all about how we relate two things to each other. We're also going to kind of jump ahead. We're going to discuss the if statement, if else statement here shortly. But to use relational operators, we almost always have to be asking some kind of question, right? And so I'm using if statements here. And the way an if statement works, if you're not familiar yet, is we just have the keyword if, and then we have a Boolean condition. Remember, Boolean stands for true or false. And so here I'm saying if A is greater than B. And we know that A is 10 and B is 20. So here, if A is greater than B, it's going to print out A is greater than B. A is not greater than B, so this will not print out. If this resolves to false, A greater than B, so if the Boolean condition inside the parentheses is false, it will skip any code that's in these curly brackets, right? Because this is the if statement block. This is the opening curly bracket. This is the closing curly bracket. This is what will execute if this condition, whatever it is, resolves to true. In this case, it's false, so it's going to skip it, right? If A is greater than or equal to B is also going to be skipped, right? A is 10, B is 20. So this will skip, right? This will not print. Then we've got A less than or equal to B. We could also just say A less than B or A less than equal to B. Same kind of thing you've been working on since, fundamental math. We've got less than equal to, greater than equal to, as well as equal to, and not equal to. So greater than equal to, less than and equal to. And then if we want to check if two things are equal, so just so you know, this will print out because A is less than or equal to B. If we want to check if two things are the exact same, then we use two equal signs, right? So this basically saying if A is equal to B, if they're the same exact value, if they're both 10, or if they're both 20, or if they're both the same, whatever they are, then this if statement will be true and this code will execute, right? In this case, it's not. A is 10, B is 20, so this will not print. The last one is not equal to. And in programming in most languages, the exclamation point is what means not, basically. When I'm looking at code and I see an exclamation point, I actually read it as the word not. So here it's if A is not equal to B. And in our case, we do know that A and B are not equal. So I would expect this to print out. So when we run this again, and we've already got the output here, but I would only expect to see two of these print out. A is less than or equal to B, and A and B are not equal. And that is exactly what we see here in the output. So relational operators, less than, equal to, greater than, equal, I should probably read them in order. Greater than, equal to, less than, equal to, equal, meaning are they actually the same, as well as not equal. These are the relational operators, and we use them to relate two elements. Is A greater than B? Is C less than D, right? The final type of operators in Java are called the logical operators. And again, we use these when we're doing multiple Boolean, basically when we're comparing multiple things. So these are and, the short circuit and, or, the short circuit or, not, which is slightly different than the relational operator not equal to. And then this little caret or top hat here is called the XOR, exclusive OR. And these are called logical operators. So let's see how they work. In this case, here in this if statement, we're saying if A is greater than 5 and B is less than 30. So this if statement will only execute, this line of code will only execute if A is greater than 5 and B is less than 30. In this case, we do know that A is 10 and B is 20, so both of these are true. Therefore, this will print out, and that's why we see it here in the output. A is greater than 5 and B is less than 30. Immediately after we learn about the and, it's time to learn about the short circuit and operation. Basically, 100% of the time we're doing logical operations, we want to use the short circuit, meaning we just use the ampersand, the and sign twice. What this does is that because both of these have to be true, A greater than 5 and B less than 30, because they both have to be true, if the first one resolves to false, so let's say that we did A less than 5, that's false, right? We know A is 10, so A less than 5 is false. If this resolves to false, and it's a short circuit and, the JVM Java, they won't spend the time required to do this operation because this and operation has already failed. If the first one is false, there's no way that this and operation will ever resolve to true, right? Because we need them, in an and operation, we need this to be true and this to be true. If so, let's do, for instance, this if statement, right? If one of them is false, the whole condition is false, right? And so anytime we're doing logical operations, we want to use the short circuit and the short circuit or, which I'll talk about in just a second. Why does the single and exist? Well, it's there. Maybe it predates the short circuit. It's also used for an entirely separate topic called bitwise or bit shifting operations, which, punt on that for later. It's interesting stuff. It's not that useful on a day-to-day basis. What is very, very useful is the short circuit and operation. We use it all the time. If this is true and this is true, and you could also say, if this is false and this is false, right? So it doesn't have to always necessarily be true and true, but we just need both of these things to be the same, basically true. Sorry if that's a little confusing there. The next one is the OR operator, and the OR is the vertical pipe, we call it in programming. And this just means if this is true, I'm just going to set that back. If this is true or this is true, so if A is greater than 5 or B is less than 5, then go ahead and print this out. And you'll notice that it does because one of those is true. And in an OR operation, only one needs to be true. One or the other or both, actually. Same thing goes in an OR for the short circuit. We just use two of these pipes. And in a short circuit OR operation, if the first one is true, right, A greater than 5, that's true. The OR operation already has enough information to know that it has passed, right? One of these is true, therefore I'm going to print this out. And so if the first one is true and we use a short circuit OR operator, it doesn't take the time or resources needed to do the second operation, B less than 5, because it's irrelevant. We already know one of these is true. Only one needs to be true in an OR operation. So I'm going to save my time. I'm going to skip this B less than 5 comparison, and I'm going to go straight into this if statement. So this is the short circuit OR. Same thing. If you're using an and or an or to do a logical operation, basically 100% of the time, I can't think of any good reason why you wouldn't use a short circuit operator. It's just a little bit more efficient always, right? So two more. One is just the not operator. So, and this is an interesting one. So I'm declaring a variable here called Boolean test equals false, right? And so this variable test is currently false, and not basically just means give me the opposite of whatever this is. So what is the opposite of false? It's true. What is, or you could read this, what is not false? True, right? That the inverse of false is true. So not false is true. So this actually resolves to true, and we're going to print out test is false. And you'll see down here, it does print out. So not, using the not operator all by itself, it basically just means put the word not in front of whatever. Like if not, we use it all the time later in Java when we're using various methods. But here it's basically just saying, give me the opposite of this, whatever this Boolean variable is, right? So if I set this to true, not true is false. This would resolve to false. This would not print out, right? It's a little confusing, a little interesting, but just to know that you'll see that. You'll see the exclamation point used all by itself. Read it as the word not. And the last one in terms of the logical operators is the XOR. And XOR, it's literally spelled out XOR, XOR, and that stands for the exclusive OR. And what exclusive OR means is that one can be true or the other can be true, but certainly not both, right? And so one or the other, not both. So if A is greater than 5 and B is greater than 30, this is true, this is false. So this will print, right? If I said B is less than 30, that's true, right? Because B is 20, A is 10, and B is 20, so these are both true. If I was to run this, like I'll just go ahead and run it, this last line, the XOR, will not print because they can't both be true. XOR is exclusive OR, only one can be true, and we'll notice that that line did not print, right? And if I switch this back to greater than 30, the first operation, A greater than 5, is true. The second operation, B greater than 30, is false. Therefore, this exclusive OR will pass, and this line will be printed. Just run this one more time here. There we go. And you'll see that it printed it as we expected. So those are the operators in Java. How we operate on our primitive and oftentimes object data types, right? We've got arithmetic operators, which are addition, subtraction, multiplication, division, and modulus, which modulus gives us the remainder of a division. We've got relational operators, less than, equal to, greater than, equal to, less than, greater than, equal to, and not equal to. And then we've got the logical operators, where we're basically saying, if this is true and, all capitals, this is true, then do something, right? Or we have, if this is true or, capital, OR, if this is true or this is true, then do something, right? So there's the and, the or, the not, which just means basically not. If not false is true, right? It's a little confusing, but it is what it is. And we use the exclamation point all the time to basically say, give me the opposite of this value. And then the last one is the exclusive OR, which we shorten to XOR. And this means one can be true, the other can be true, but they cannot both be true. It has to be exclusive. Only one can be true. And those are the operators in Java. And as we get going here, one thing to keep in mind is we're just kind of throwing information at you, is all of these concepts and variable types and operators. We're about to go into if statements and loops and arrays, right? They're all just kind of tools in our tool belt to help us accomplish given tasks, right? So if you're just learning Java right now for the first time, your objective, right, is to learn all of these fundamental tools so that you can start to solve more complex problems, right? The very first step is learning what data types we've got, learning how we operate on those data types. Next, we're about to go into kind of what I call conditional statements, right? If this is true, we've already used some if statements. We're going to talk about some loops, so if I need to do something multiple times, and arrays, which are the most fundamental data structure in Java. If this is a little confusing, don't worry. The idea is to just start getting exposure to these concepts, to iterate on them. We're pushing all this code up to GitHub, so we'll share the link with you. I'll have it in the video description below. Just watching these videos, writing this code, trying to replicate and just kind of play around with these concepts, and they'll start to make more and more sense. And then you'll be more comfortable moving to the next step, and iterate, practice, go to the next step, iterate, practice, go to the next step, right? And then after a little while, typically it takes a couple of months all of a sudden you realize that you know Java and that you can kind of code whatever you want. And it's this big aha moment. And by watching this video and studying these concepts, you are taking a very legitimate, good first step in that direction. So keep on going, even if this is a little bit confusing, okay? Next, we're going to talk about conditional statements. So we've got the if-else statement and the various loops, right? So we've already kind of talked about the if statement. The if statement is simply if this is true, do whatever's inside the blocks, right? This can be multiple things. Like it doesn't need to be, oops. In this case, this opening curly bracket is the open, basically where this if statement starts. And this closing curly bracket down there, that's the end of the if statement. So if A is less than B, which is true, all 4 of these things will print out, right? And you can put whatever code you want in there. Just so y'all know, these curly brackets, they define what is called a block of code. And since we're here, in Java, a variable it has what's called variable scope. And that scope is defined by whatever code block that variable is in. So for instance, this whole main method, it starts at the top and it goes all the way down to here, line 47. These variables A and B, they can be used anywhere inside this main method, because what defines a variable's scope in Java is its closest and closing curly brackets. So this is the opening one, and anywhere in between the opening curly bracket and the closing curly bracket down here, I can use these variables A and B, right? They're in scope. But let's say that I created a variable here, int c equals 20. I go over here, I can't say c, like for instance, change the value to 30, c equals 30. I can't do that because c on line 26 down here, this is out of scope, right? C only exists inside these curly brackets. It's called the variable scope. And again, it's used to make our applications as efficient as possible in terms of memory and all the general resources that go into running this. Variable scope kind of, instead of having 1,000 variables that just kind of live all the time anytime our application's running, the variable only exists and is only accessible inside the block of code, which is defined by the nearest and closing curly brackets in which it exists, right? So that's variable scope. It's an interesting and important concept to understand right at the beginning. We don't need to print this out 4 times, so I'm just going to print it out 1 time. One other small detail here is that in an if statement, or kind of in various different scenarios in Java, if you're only doing one thing in an if statement, you actually don't need curly brackets. You could actually write it like this: if A is less than B, then do this, right? So usually you'll still see it on the next line to kind of indicate if A is less than B, then you can do this. The moment I do, let's say, 2 operations, even if I've got this tabbed over like this second line, line 20, it's not part of the if statement, right? It's its own thing. It's going to execute either way. If I wanted that to only execute if A is less than B, then I must use curly brackets to say that both of these lines of code are inside this if statement, right? So I almost always use curly brackets, even if I'm just doing a single line of code, even though they are optional, because to me it just makes it cleaner, makes it more obvious. I try to make my code as easy to read as possible. So that's the if statement. If is the keyword, and then in parentheses we have a Boolean condition, any kind of condition that resolves to true or false, right? A less than B, true. A greater than B, false, right? And any kind of condition in Java that returns true or false can be used inside these parentheses. Once we understand the if statement, it's time to talk about the if-else statement. So if A is greater than 5, which it's not, A is 3. So if A is greater than 5, do this. Otherwise, do this, right? So it's going to be a one or the other situation, if else, right? If this is true, do this. Otherwise, else, do this, right? Pretty simple, if else. The next thing is the if else ladder. So this is when you want to check multiple conditions, like asking questions, not just if this is true, do that, otherwise do this. Here we're saying if A is equal to 1, print out A is equal to 1. Otherwise, if A is equal to 2, print out A is equal to 2. Otherwise, if A is equal to 3, print out 3, and then kind of the catch-all, else A is not 1, 2, or 3. We know that A is 3, so it's going to give this one false, this one false, this one true, so it's going to print this out. And then because this is true, it'll skip the last else, right? And that's it. So let's run that and see how it goes. So A is less than 1 seems like a bad message that I've got there. A is less than 10, I should say. So it's just a user error. But we do expect that to print because 3 is less than 10, A is less than B. And then A is not greater than 5. So that means that this printed, which we expect because A is not greater than 5. So it skipped this else statement and it went to the else block. And then A is 3. So A is not equal to 1, so it skipped this. A is not equal to 2, so it skipped this. A is equal to 3, so it printed this out. And because this worked, because this else if was true, it skips the other else. This else would only be hit if none of these were true, right? Only in an if else if ladder, only one of them is going to execute, right? Or none of them. If you know, you could just, for instance, you don't necessarily have to have a final default case. And if A was 4, then just simply nothing would happen here. And that's totally fine. Doesn't make that much sense in our scenario here. Oftentimes in an if-else if ladder, you'll see a final condition, which is just a final else, meaning if none of these are true, then let's do this one, right? But A is 3 printed out, which is exactly what we expected. So that's it. That's the if-else statement and the if-else if ladder. One other little note here is that these can be nested, right? So here, let's go into A is 3, and what do we've got? We've got B is 10. Inside here, I can say, I'm inside this else if statement, I can say if B is greater than 5, I'm going to open up, so it'll go into that here. I can do another one. If B is greater than 7, open that up. If B equal 9, just a second here, just make this a little more obvious when we run it. B is greater than 5, B is greater than 7. If B equal 9, print out B as 9. Else, if, let's say B equal 10, let's say B is 10. And then let's just say another case, else sout is just a shortcut for system.out.println, and I'll just say not sure what B is. So when I run this, and I'll just make this a little smaller so we can see it, I know that A is 3, B is 10. So in this else if statement, A equal 3 is going to be true. All right, so we're going to print out A is 3. And then I've got another if statement inside, nested within this else if statement. If B greater than 5, it is, so I'm going to expect this to print. If B greater than 7, it is, so I'm going to expect this to print. If B equal 9, it's not, so this is not going to print. Else if B equal 10, it is, so I do expect this to print. Then we'll skip over that and keep going, right? It'll also skip over this else statement because, again, this else if was true, so this final else will be skipped, right? And with a little, if this is confusing, with a little bit of practice, it'll make more sense, I promise. Great, so it printed out A is 3, which we expected. B is greater than 5, which we expected. B is greater than 7, which we expected. It skipped the whole B is 9 thing because B does not equal 9. This is false, so it skipped it. Else if B equal 10, print out B is 10, which it printed. And then it didn't print out anything else. So that worked exactly as expected. And that's it. That's the if-else statement, really. The main idea here to show you was that you can nest these things. It's called nesting, like those dolls, you know, those Russian dolls where one goes in the other, which goes in the other, which goes in the other, which goes in the other. It's kind of like that. Those are nested within each other. You can nest if statements as well as loops and all kinds of other things in Java as many times as you want, and it'll work just fine. That being said, if you find yourself nesting things, more than 3, 4, 5 at most times, there's probably a better way to do it, right? So if you see yourself nesting code like 7, 8, 9 levels deep, like here I've nested this 1, 2, 3, kind of 4 in, and it already makes me uncomfortable how deeply this is nested. If I need to do this, I can, but there's probably a better way to do this. And in this particular case, there's certainly a better way to figure out what B is, right? Here I'm just trying to demonstrate the if-else statement, if-else ladders, as well as nested if statements. So that's the if-else. It's that simple. If-else allows us to, basically, it's a conditional statement. If this is true, do this. Else, if this is true, do this. Otherwise, do this, right? And so it's kind of like a if this, then that type of situation. Cool. So now that we understand the if-else statement, let's look at loops. And loops are incredibly useful, very, very commonly used concepts in all programming languages. And there's a few different type of loops in Java. The first, and the while loop and the for loop are probably equally as common, but a very, very common one is called the while loop. And in a while loop, we use the while keyword. And basically, it's going to continue to loop until while the condition inside the parentheses is true. So here I've got int I equals 10, and I'm saying while I is greater than or equal to 0, print out I dash, and then decrement I. I minus minus is the same as saying I equals I minus 1, right? So I will go from 10 to 9, and then on the next loop, it'll go from 9 to 8, right? We use the shorthand I minus minus or I plus plus. It's just shorthand for incrementing and decrementing a counter like that. So after this runs, I would expect to see the numbers 10 through 0 printed out on the same line, because I'm actually not saying print line. I'm saying just print, not print ln. So let's go ahead and run this, and I should expect to see 10 through 0 printed out on a single line first. And I do. Great. So that's a while loop. While this condition is true, keep looping. The important thing to remember with a while loop is that you need a way to get out of there, right? So imagine that I didn't do this. Imagine that I didn't decrement I. In this condition, I will always be greater than or equal to 0 because we have nothing that changes I. I is 10, and there's nothing that changes that. 10 will always be greater than 0, meaning this is an infinite loop. And if I was to run this, just to show you, it's going to print out 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, like a bunch of times. There, yep, there it is. We're in an infinite loop, right? And when you find yourself in an infinite loop, there's some red, in IntelliJ, we've got these red squares here and here that will stop the current application. So that was an infinite loop. We typically don't like those for obvious reasons. So when you're in a while loop, you want to make sure that you can get out of that while loop. In this case, I'm decrementing I. So it'll be 10, then 9, then 8, 7, 6, 5, 4, 3, 2, 1, 0. And then when it's 0, it'll go to -1. -1 is no longer greater than or equal to 0. So we will exit the while loop, right? And then it'll print out, then it'll go down to this where we just print out a new line on line 26. It'll go to whatever line of code is next after the closing curly bracket of this while loop. We can put whatever code we want inside these curly brackets. We can create new variables. We can do if statements. We can call functions and methods. We can create objects. We can do whatever we want. Quite literally, whatever you want. You can do it inside an if statement, inside an else statement, inside a while loop. You can do whatever you want, right? The next one is called the do while loop. It's very similar. While something is true, continue looping. But the syntax is slightly different. It's called a do while loop. So we started with the keyword do, then opening curly brackets, and then whatever's in the curly brackets, it will execute. And then after it's executed this at least once, it will check the condition. So the only difference here is that with a do while loop, it ensures that the code inside the loop will execute at least once, and then it will check the condition to see if it should execute it again, right? They're slightly less common out there in day-to-day programming, but sometimes it is quite useful to have them, right? So for instance, I could say, let's say I'm taking in some input from the user, and I want to continue taking in input from the user until they type quit, right? I can't understand whether I should stop looping until they've typed quit, right? So inside this do while right there, I would read in the user input at least once, and I would see, did they type in quit? If so, exit this loop. If they didn't, keep looping, right? So a do while just says, I need to loop, and I want to make sure the code inside the loop executes at least once. Because it is possible, even though here we know I is 10 and 10 is greater than 0, oftentimes in the code that we write, we won't actually know the value of I. It'll come in as some argument or parameter into our function. We don't necessarily know whether or not it's true. So if I is not greater than or equal to 0, let's say I got passed into this function, into this method as -1, this will never execute, right? I is not greater than or equal to 0, so this will never execute. If we want to avoid that situation, we want to make sure that it executes at least once, Then we use a do while loop. And that's it. So one other note about while loop, typically this is for indefinite iteration. We do not know how many times we're going to loop. Here, we're using int I equals 10, right? So we know that we're going to loop technically 11 times. 10 to 0 is 11 numbers. Oftentimes, like I mentioned, though, this number, it's going to come in as some kind of variable. We don't necessarily know how many elements we're going to have to loop over. We just want to continue looping until something is false. So indefinite iteration. Same thing goes for the do while loop. In the for loop, we call it finite iteration. So I know exactly how many times I want to loop. And I'll start simple. And I'll start real simple. C equals 0, while C is less than 10. C++, like the language. So in a for loop, we've got some interesting syntax. I've written it down here. For, and then we've got the initialization, which is int C equals 0. And then we've got the Boolean condition, which is until when should we continue looping? We're going to continue looping until C is no longer less than 10. So while C is, you can basically read this like a while statement. While C is less than 10. And then on each iteration, we're going to increment C. So this is going to print out on a new line 0 through 9, right? So, let's run this, and it does. So this last section here is from the for loop. It prints out 0 through 9, each on a new line, because we're doing system.out.println. And for loops are very, very common. Just get used, if this is the first time you've seen these, just write out like 10 of them, right? Just get used to the syntax. They're super common. They're also very, very useful for working with arrays, because this variable like C in this case is a really good index to use when we're processing arrays, which we're going to talk about in just a moment. So a for loop is for finite iteration. We know exactly how many times we want to loop, right? In this case, int C equals 0, while C is less than 10. On each iteration, increment C, and then print out C. And this is typically how you'll see them. But you could also do something different. Let's say I want to start at 100, and I want to keep looping while C is greater than or equal to 0. And then on each iteration, I want to decrement C by 2. So I can say C minus equal 2, which is the same as saying C equals C minus 2, right? And now if I print this out, let's just do it all on one line. It's going to print out 100, 98, 96, 94, 92, 90. It's going to print out every other number all the way to 0. And I don't need 2 zeros there. And there's no spaces, so it's hard to read. So let's go ahead and put a space in there. So on each loop, it's going to print out C and then a space. Yeah, and that looks good. 100, 98, 94, 92, 90. So we're just iterating step by step by step. C starts as 100, while C is greater than or equal to 0. On each loop, decrement C. So on the first loop, C will be 100. On the second loop, C will be 98. On the third loop, C will be 96. On the fourth loop, C will be 94, and so on. There's one other loop called the for each loop, which we're going to talk about in just a second, because the for each loop only works when we have a collection, such as an array, which we're going to discuss next. So let's go ahead and jump in. So, well, before we jump in, quick summary. In Java, we've got 3 very, very commonly used loops, and a 4th that we haven't covered yet. The first is the while loop. While some condition is true, continue looping. The second is a do while loop, which is basically the same as a while loop, but it ensures that the code inside the loop will execute at least once before that while condition is checked. If it's true, it'll continue looping. If it's false, it'll move right down. But the code inside the loop will have executed once. And then the third, and this is an extremely commonly used loop in Java, is the for loop. And we have an initialization, a Boolean condition, and an iteration that goes inside the parentheses. So while loop, do while loop, for loop. The sooner you can get really comfortable with these and they just kind of feel like second nature to just write them out without looking at any notes or any resources, the better. We use these things on a day-to-day basis as developers every single day. For loops, while loops, if statements, primitive data types, day-to-day programming stuff. So good thing that you're here learning this stuff right now. Now, let's jump into the arrays. And an array, and we're jumping kind of fast here, so I don't expect all of this to just sink in, especially the first time that you're watching this. But an array is the most simple data structure in Java and in basically every programming language. They have different names, and we can call them a list, we can call it a collection, we can call it an array. An array is typically a type of collection in Java. They can be called dictionaries. In Java, the syntax to create an array is just a collection of data. Like, for instance, what I'm creating right here where I've highlighted is an int array. And the way that we create an array is with these square brackets. We say, I want an array of type int, and the square brackets says that this is an array. So the way I read this is int array nums, which is the name of this variable, equals new int array. And then in Java, it's 100% required that we indicate the size of the array so that the JVM knows how much space to reserve in memory, right? So here I'm creating a data structure, an array with a length of 5. And the way that this really looks in my head, I think I can annotate here. Get some draw. I'm going to get a shape. Basically, the way that an array looks in my mind, is I see it kind of like a ladder. And each rung in the ladder is one of the elements. So that's 1, 2, 3, 4, 5. Not the prettiest artwork there, but this int array here, it basically int array nums equals new int array 5. It creates a data structure that looks like this, right? It's kind of like, I literally see it as like a ladder on the wall, and at each rungs, including the bottom and the top, right, is a spot where we can put, in this case, an int, right? Each one of these spots is is accessed or addressed by what we call an index, right? So that index right here, let's say we're going to start at the bottom. So at the bottom, it's the index of 1, and then it goes up to 2. It just depends which way you're counting here, right? Sorry that these are not, let's see if I can move these around a little bit. There we go. These numbers that I put on the side here, these are just to show you the index or the address of each element, right? So this is the 0 index, this is the 1 index, this is the 2 index, this is the 3 index, this is the 4 index, right? And so over here in my code, you can actually see where I am assigning values to these indices, right? And please keep in mind that you can imagine this array in whatever orientation you want, right? It's just the way I like to see it, like a ladder, and inside each one of the rungs is a spot for an element, right? The very bottom gap, that's the index of 0. The gap in between the first and second rung, that's the index of 1. The gap in between the second and third rung, that's the index of 2, right? Because in arrays, we start at 0. And even though this is a length of 5, pardon me, I'm on a sneeze. Excuse me. So this array has a length of 5, right? But because we start counting at 0, the last index is 4. 0, 1, 2, 3, 4 are the indices. The length is 5. The final index is 4 because we start counting at 0. So here I'm basically saying at the index of 0, I want to put the number 1, 2, 3. So that's like putting 1, 2, 3 right there. At the index of 1, I want to put the number 4, 5, 6. I'll fix these up afterwards. At the index of 2, I'm going to put 9, 8, 7. At the index of 3, I'm going to put 6, 5, 4. And at the index of 4, I'm going to put 56. Fix these up a little bit. So we've got an index, which is basically like an address of some piece of data. And then we've got the actual data that exists at that address. So at the index of 4, in this array called nums, is the value 56. At the index of 1 in this int array is the value 456, right? And the way that we access, or the way that we assign values to arrays, is we say the name of the array followed by the address, which we call the index in square brackets, equals some value. So I'm saying nums at the index of 0 equals 1, 2, 3. Boom, that set that 1, 2, 3 right there. Nums at the index of 1 equals 4, 5, 6. So that would set that 4, 5, 6 right there. nums at the index of 2, 987, nums at the index of 3, 654, nums at the index of 4, 56, right? And so now we've got this nice little collection. It's called an array. Our variable name is nums, and this little nums variable has a collection of data in it. In this case, it's got these 5 numbers. So like I mentioned before, the for loop is very, very useful when we're using arrays, because this variable that we declare almost always with for loops, like int I equals 0, and then we're going to iterate as long as I is less than nums dot length. The dot length, anytime we're iterating over an array, instead of saying, like, we could right here, we could just say less than 5, because we know the last index is 4, so we could say I less than 5 right here, but it's always good, best practice when iterating over an array to say nums dot length, which will return 5. So while I is less than 5, so for 0, 1, 2, 3, 4, and then on each iteration I plus plus, here we're saying int num equals nums I. So I'm basically showing you how to assign a variable into an array here and how to read a value out of an array here. So int num equals nums I. So whatever value is at nums I, in the first, like on the first loop, I will be 0. So it's going to say nums at the index of 0 is 1, 2, 3. So it's going to assign the number 1, 2, 3 onto this variable num, and then it's going to print out 1, 2, 3, right? So and then it's going to print out 4, 5, 6, 9, 8, 7, etc. So let's see if it does that as we expect. And it does. 1, 2, 3, 4, 5, 6, 9, 8, 7, 6, 5, 4, 56. So, and just for fun, I can set a little breakpoint. I could just click right here next to the line number, make a little red dot, and right click anywhere and debug. And what this will do, it'll run the application and it'll stop the flow of execution wherever you set the breakpoint, it's called. So, and then I can use these little controls over here. They're probably a little bit small on your screen, but there's these controls right here. And these are the different controls to step over this line, step into this line, forcefully step into this line, and step out, which will all make sense as you do more. We won't go too deep on that right now. I'm just going to use step over. So here, when I say step over, if I go over to the debugger tab, I can see that I is equal to 0, num is equal to 1, 2, 3. That's this line right here. Int num equals nums I. And then system.out.println num. So if I go back over to the console and step over, we'll see that 1, 2, 3 print out. And now we're going to see 4, 5, 6 print out. And now we're going to see 9, 8, 7 print out. And we're just going to keep looping, accessing each element in the array until I is no longer less than nums.length. So here, if we go back over to debugger, I is 4. Well, that I was 4 on the last loop. So if I incremented one more time, it would be 5, which is no longer less than nums.length. So we jump out of it, right? Now we're in the for each loop. So we've got a collection now. We've got this collection called nums. It's an int array, but it's a collection of things. Now that we have a collection, we can use what's called the for each loop. So this is another for loop that has some distinct syntax. And the way that I read this is for each int that we're going to call n in nums, and all I'm doing is printing it out, right? So in this case, n is not an index or a counter like I is. I was 0, 1, 2, 3, 4, right? In a for each loop, n is the actual value in the array, right? So on the first loop, n will be 1, 2, 3. On the second loop, n will, let's get some more space here. On the second loop, n will be 4, 5, 6. On the third loop, n will be 9, 8, 7. On the fourth loop, n itself will be 6, 5, 4, and we'll be printing out n each time. So if I stopped it on the last one, but if we run this, we'll see it all printed out. Oop, just going to get rid of this breakpoint and resume the program. So that's this second bit of printing here. That was all printed out by the for each loop, right? So for each int that we're going to call n, and then I read this colon as in nums. For each int called n in nums, do something. And n is the actual value in that array. A for each loop can only be used with a collection, and it's guaranteed, unless you use like the break statement, it's guaranteed to visit every single element in that collection. So if I've got this array, it could have 4 elements in it. It could have 4 million elements in it. If I use a for each loop, it will visit each one of those elements in that collection no matter what. So it can be useful when you just want to do something on every single element in an array or a collection of any kind. So one last thing here before we already covered the for each loop. We're going to talk about two-dimensional arrays. So I'm just throwing all this information at you, but you understand a single-dimensional array now. There's also this idea of a two-dimensional array. So you could think of a single array like this. This is a ladder in my eyes on its side. This is the 0 index, the 1 index, the 2 index, the 3 index, the 4 index. We can also have a two-dimensional array. And effectively what that means is that at each index is another array, right? So let's call this let's go back to our vertical ladder. Let's imagine that it's a two-dimensional array, and at the index of 0 is another array. And at the index of 1 is another array. And at the index of 2 is another array, right? It's an array of arrays. It's two-dimensional, right? You can think like a block of numbers, like a multiplication table, right? It's at each index of our ladder, for instance, imagine a ladder on the wall. At each index, at each gap in between the rungs is another ladder going sideways with its own indices, right? So the way that we typically operate with two-dimensional arrays is with a nested for loop or a nested for each loop. And in this case, we're saying for int I equals 0, while I is less than num2d.length, so this is the length of my array, and I'm saying I want let's call it the vertical axis to be a length of 3, and at each horizontal axis, it will be a length of 4, right? And so I'm saying for int I equals 0, while I is less than num2d.length, which is 3, I++, and then I'm immediately going to do another for loop inside of this for int j equals 0, and this is where it gets a little tricky. J is less than num2d at the index of I dot length, because num2d is a two-dimensional array. So at the index of I, let's say at the index of 0 in num2d, on that vertical ladder, you're going to find another array with its own length, right? So for int j equals 0, j less than nums2d at the index of I dot length, j++. And this is how you assign a value into a two-dimensional array. You give it the address of the first index and then the address of the second index. So on this first loop, I and j will be 0. So this will be num2d at the index of 0, 0 equals I times j. So 0, 0 is this spot right here. And we're going to say I times j equals 0, right? 0 times 0 is 0. Then we're going to loop over this inner loop again. This inner loop is going to do everything. It's going to do its whole cycle until j is no longer less than num2d I dot length. And then it'll exit and it'll go back up to this outer for loop, and I will increment to 1, and we'll start the process over. So let's just walk through this for a second. Well, if we were really going to write this out, I'll actually do it here. On the first loop, I is always 0. So 0 times 0 is 0. And then 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. And that's the length, 4. Then we're going to exit the inner loop. I is going to become 1. And then we're going to go back down to the inner. We'll exit the inner loop, go out to the outer loop. I will increment to 1, and we'll go back in here to the inner loop. J resets to 0, and we start the inner loop process over. So now I is 1. 1 times 0 is 0. 1 times 1 is 1. Sorry, j is going to increment from 0 to 1, so 1 times 1. I and j are now 1. I is 1. J will increment to 2. 1 times 2 is 2. I is still 0. 1. J will increment to 3. 1 times 3 is 3. We're going to exit the inner loop. We're going to go back out to the outer loop. I will increment to 2, and we'll go back into the inner loop, which starts over. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6, right? Because j is going to be increment, 6. And so this is what the actual two-dimensional array would look like after, I'll just delete this one because it's not really helping us. After this for loop runs, right? A bunch of zeros. This is the index of 0, 0. If somebody said, what's the value at the index of 2, 2, right? So I would say, okay, 0, 1, 2, okay, 0, 1, 2. That's it. At the index of 2, 2, num2d at the index of 2, 2 would be 4. Here, we're going to use a for each loop, a nested for each loop, to print out each element. Oh, cool. I was right. That is because we already ran it once. But this is a for each loop where we're going to say for each int array that we're going to call numbers in num2d, right? Because at each index of this array is another array. So we're saying for each int array that we're going to call numbers in num2d. So now we have this array called numbers. And then we have another for loop where we say for each int that we're going to call n in numbers, print out n plus a dash, right? So here, like we can just, I'll go ahead and put a breakpoint here, debug. Go to the console, zoom in a bit, and 0, 0, 0. You can kind of see the way that it loops. Print a new line. Now I is 1. If I go to the console, right, you'll be able to see that, or sorry, the debugger, you'll be able to see that. Oh, sorry, no, we're not in an I. My bad. We're in a for each loop. I'll go back to the debugger. Sorry, the console. And you can see that now we're on the third loop. So we've just gone down to the third line. We're going to go into the inner loop and iterate over all those numbers at that third level of this two-dimensional array. Great. So if you're first getting started with all this, right, I don't expect, like we've just gone all the way from what is a Boolean variable all the way up to what is a two-dimensional array and how do we iterate over it using a nested for each loop, right? That's a pretty big amount of information that I've just covered here really, really fast. So if this is seeming confusing and it's all not making perfect sense, I would expect that, right? So please don't get down on yourself or get too hard on yourself if this is confusing, right? What this takes is practice. And what I wanted to do here is give you as much practical information as possible to get started quickly in working with primitive data types, working with variables, the assignment operator, int I equals 10 and stuff, as well as all of our operators like arithmetic operators, relational operators, logical operators, right? And then the very, very common if else and if else style statements, what I call conditional statements. If this is true, do something, else do this, right? And then lastly, then we jumped into arrays where we talked, then we jumped into loops where we discussed the while loop, the do while loop, and the for loop, right? Each of them with their own syntax and their own kind of use case. And then we jumped into arrays. An array is just the most fundamental data structure in really any programming language. And the syntax looks just like this. We use the square brackets. When we create an array, we have to say how long it is. When we want to assign a value into an array, we say, for instance, the name of the array, which in this case is nums, and then the index or the address of where you want to put some data. And so you're basically here, we're saying, I want to put the value 1, 2, 3 in this array at the address or index of 0, right? And if we want to get something out of an array, then I would say something like int num equals nums at the index of I. In this for loop, I is going to start at 0, so it's going to give me the first one. And then I is going to increment to 1 on the next loop, so it'll give me the second one. And then I is going to increment to 3 on the 2 on the third loop, which is going to give me the third element because the counting starts from 0. So the length of the final index of an array is always 1 less than the total length. So then once we had arrays, we've got our first data collection. Now we can start using the for each loop, which reads like for each int, which is the data type, n, which is the variable name, in nums, do something. And n is the actual value in that array, right? When we start looping, n will be the first value, then it'll be the second value, then it'll be the third value, then it'll be the fourth value, and so on, until we visited every single element in that collection. So lots of information there. I've flown over it real fast, but hopefully it was useful. Let's head back over here to this presentation. If you're interested in learning more, this is a 3-day series we've got going on here. Tomorrow we're going to be talking about the principles of object-oriented programming. On day 3, we're going to talk about basically acing the coding interview with creating custom linked lists and hash maps and kind of understanding data structures in general. Please check out our YouTube channel. We're adding new stuff on there every week. We've got all kinds of great tutorial videos and examples and just kind of, all kinds of cool concepts, primarily Java and Python focused, but we're moving also into a bit more JavaScript, and we've also got quite a bit of data science stuff. So check out our YouTube, lots of great stuff on there. If you want to take it a step further, also check out our online learning platform, platform.codingnomads.co. You can create a free account. We've got all kinds of really, really great comprehensive courses in there, like Java programming, Python programming, web development, data science, SQL and databases, Git and GitHub, and new courses coming out basically every month. Half of them are free. The other half have a very large and extensive free preview. So please feel free to check it out. It's quite nice, platform.codingnomads.co. And thank you for joining. I hope this has been useful. I hope you've learned a bit. This has been an introduction to Java, variables, data types, operators, if statements, and loops and arrays in just over an hour. So if you made it this far, great work. Keep going. Hope to see you tomorrow. Check us out on YouTube. Check out platform.codingnomads.co when you're ready to learn more, and we will see you soon.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.